Thanks for being here, guys. I'm a bit nervous. It's been a while after the COVID and the public speaking and stuff. But what I'm hoping to have, for you, not to be just 20 minutes older after this presentation, but to fetch something out of experience which I want to share. In a nutshell, I will have three cases and a bit of something like a conclusion, and I will dive you through those cases, what we achieved, what was the reasoning behind different types of decisions, and what we were expecting from those things. Okay, let's start from the brief intro. My name is Kirill. I've been in software development more than 13 years, and it happened that way that eventually I was the first machine learning project which I was I delivered was in 2012. It was generative art for Samsung. It was really fun, and along my career I was lucky enough to touch different aspects of machine learning, especially when it comes to e-com and the automation of different types of communication with the customers. A bit of highlights, 13 years, I've managed maximum 120 developers, and my biggest application, the biggest user base was more than 15 millions that was under my management. And what I personally like, G-com, monetization, e-com, I really enjoy all the processes happening inside those domains, and how can company or me as a professional can succeed in those domains. And personally, I have two kids, right? I'm a big fan of gaming as ever since my childhood, and of course a bit of sports. Okay guys, let's then continue with the cases, right? The first case which I want to share with you is the case of building the smart offering system. In a nutshell, the whole thing works like this. We had a huge, pretty big application. This application aggregated around 3 million of active user base every day, and this application as well had already a lot of operational burden. It was heavily on production, so a lot of different types of monetization strategies, pricing architecture and things, and we decided that we need to make this offer more automated and to achieve a certain goals. The idea was, okay, we have a couple of algorithms, and the idea was to implement the naive bias algorithm in this domain. And let me share a bit more what is naive bias. Naive bias is pretty simple algorithm. It's all over the place, and it's been the first time I faced it it's in 2013 as far as I remember. Why it's important? Because as long as this algorithm is being used in production by different types of companies, so it will be easier to find snippets and the applications of this algorithm. And why we decided to use bias, basically there's three main points. Bias requires really not extensive amount of data to be trained upon, and the thing is about bias, it's training all the time. It's happening all over the time when this solution is in production. And let's be honest, my naive bias doesn't require that much of data science time to prepare those features and to get the results. And now let me walk through the context. I've shared a bit that we had a mobile application with server side, this application had around 3 million of active users, and the problem with this application was not the problem, the issue with all applications which are already in production. This application has already had huge acquisition costs, and the problem with those acquisition costs is not that they are huge. The problem with them that they're always constantly growing, and the companies like this, big companies or companies at this stage of their development, they always require additional tools for to convert their users from non-payers to payers, to be able to decrease the acquisition cost, and basically to make the unit economy positive in that case. So we granulated before starting the development and before starting the envisioning of this product. We had two main goals in front of our team. The first one, of course, to increase the conversions from non-payers to payers, pretty straightforward and pretty simple. And the second one, to improve early stage monetization. What does it mean? There are huge tons of users coming through the funnel to CRM-ish solutions of that company. And the problem is like before those users are reaching their maturity, basically for data science, for monetization guys, they are kind of blind spots. And in that case, we've delivered like something like this system. Yeah, it's pretty created with a huge strokes, but let me dive you a bit through the data streaming here. So we have like an offering tool in the middle. This offering tool is basically like any types of like personalized communication. The idea of this tool was pretty straightforward. We aggregated the profile of the user, and we were able to communicate with this user within seconds within this huge ecosystem. But on top of it, we've decided to build up this naive bias module and to feed this module with all types of different offerings. And by offerings, I'm saying items like communication, messaging, monetization things. And like this offering system, naive bias was kinda smart guy here, and you can see it. So backend data storage. This is the backend data storage of the master application. We were sourcing data to our offering tool, and this offering tool we were forming the pretty slim and fast player profile. But this offering tool, as well with like one of the ETL steps and for this tool was to create the storefront for naive bias. And then naive bias was the one who was making decisions what to show to any types of our users. And like you see that after getting this data to offering tool, we were able to communicate with any types of clients and any types of like client applications here. I think no questions, right? It's not that format. In the respect of Devworld, let me give you the notion how it works like, from technical perspective. So we have like two applications, master application and offering tool. Master application consists of like backend written on C++. I'm not sure about Java. I think I made a mistake. And my SQL as a storage and application clients, Android, iOS, and of course they had more, but I will touch upon this like a bit later. An offering tool, it's Java, Scala, and HBase as a storage, and of course naive bias was fully written on Scala, purely on Scala. Yeah, and now we made it like live. This application is still in production. What we've managed to achieve. The meaning, the first thing, the experiment. The experiment was like, okay, let us get like around 10K of non-payers, like who've been just registered like in the master application. And then the idea was not to damage the core audience, not to damage the monetization strategies, not to damage the current pipelines of getting those users, onboarding of those users. And what we achieved, like the conversion, we showed the uplift around like 20%, but like let's be honest, that was not like 20%, like we had like 4% of conversion and then we had 24. No, it was 4 plus 20% out of this 4. But still, when it comes to like bigger scales and those applications were pretty much big, that was a huge win for the company, for the team, and especially for the team. And of course, like the interesting part about operation and automation of operation here, by introducing this system, we managed to relieve a bit of operational burden. Of course, it's hard to say that we were able to get rid of operations. No, it's not like this. But the good thing and the real achievement that we were able to cover 3 more pricing slots. In that case, like throughout just like automation of operations here. Okay, this what it counts for the first case. Let me move on. Now the second case. The second case came evolutionary, right, from the first one. Because yeah, we had naive bias, and now how we can make it a bit more interesting. The idea was, okay, let's start working with pLTV, predicted LTV, one of the holy grails of like. First, like in gaming, and now pLTV is one of the holy grails on e-com in general. The idea of pLTV, if you know how much money your users will bring, like in the future, you can plan your like marketing, CRM, or whatever activities. You can plan your unit economy basically. And again, the same decision proving process here. Linear regression was. It's not simple. It's not that simple as naive bias, but it's still it's widely used all over the market, and it was widely used back then. And one of the things, like, we already had like an enthusiast who had who created like this model, and based upon his test data, we were expecting 24% of uplift when it comes to conversions. But let's check. Basically, we've built, no, it's not built, we've built like a separate module to the system which we delivered like previously. Here you can see that we have naive bias, we still have this offering tool, but we've created like a data lake. No, we were not creating data lake. Data lake was there in the company already, but we created a couple of storefronts with this pre-aggregated data with predicates about pLTV of the users. And the thing is, the difference here, the naive bias in the first case was making decision about like communicating with your users, but here data lake was enriching and so the profile of offering tool, and then offering tool was making a decision how to communicate with those users. Again, when it comes to technology, it's pretty the same, and I'm pretty sure it doesn't matter what kind of technologies were used in data lake. It was just like part of data sourcing here. Yeah, and of course objectives, can we reach 24% in production, not only in test data? Exactly the same experiment design. We managed to get non-players, but as far as I remember, that was not 10K. It was a bit more. Here there were around 30K as far as I remember in the first run, and then 50K when we continued here. But unfortunately, what we figured out here, when we launched this tool, this system on production, the uplift was zero, literally zero. It worked we started the investigation. During the investigation, checking the sensitivity, KPIs of the model, we realized that we've built spam machine. So false positive was 98% of this machine was sending communication all the time. And the further investigation, what we realized, right, with this data enthusiast and data scientist enthusiast, that that guy was training his model upon training data, and then he used half of the training data in his test data. I mean, of course, model was fine and was really pretty precise with the predictions and stuff, but in production it doesn't work like this, unfortunately. But again, experience is experience, right? Okay, I think I will continue then with case 3. It's still work in progress. Here we want to build an automated merchandising tool and to make it a hybrid. Now when it comes to the context, the company has newly built B2C brand, so it will have a huge, pretty wide funnel for acquisition of those users. And to be honest, the nature of this B2C brand, it's not mono brand, it's not brand with only one provider with one supplier. It's from day one it has more than 100 of different suppliers with different goods, with different pipelines and communicating with the customers and with the stuff. So it requires a lot of attention when it comes to operation management. And the thing is, my idea was, as long as we have a huge tons of different types of offering, we will be buried under the operational burden of the stuff while trying to build up the proper pipelines and nesting our users, onboarding our users, I mean the end users, the clients themselves. And of course, the problem with those kind of products is not even just getting to the market, but also to always keeping an eye on the technical cost of ownership. And of course, out of those 2 points, we have we still have two main objectives here. And first of all, to be able to maintain the proper pipeline of onboarding of new users, giving the huge tons of the different types of suppliers. And of course, revenue, and especially added revenue from this product, should exceed at least a bit the technical cost of ownership of implementing of the system, but technical cost of ownership not only project based, but technical cost of ownership of each user within the system. Machine learning requires calculation time costs money all the time. The system here is pretty straightforward. We have GCOM, Games.com, eCom, GCOM specifically in games. So it's basically a website, huge website with mobile versions, mobile applications, and we have backend. And on top of this, we are building data processing unit. Now it more looks like a recommendation system because it works like with, yeah, I will shed a bit light about it like a bit later, but it's kind of recommendation system. And like this recommendation system, like based upon the data which we are getting from GCOM and from the clients, showing the desired order and like per user of merch. So basically it's kind of more weights of different items when it comes to different users here. How I'm planning to achieve this? We need a hybrid approach here. Like my personal belief that like we need to incorporate like the two algos. Like the first one, like naive bias, the classificator, and the second one, and k nearest neighbor, like clusterization thing. Not classification, yeah, still, but it's kind of in between. The idea here that we have huge tons of users and we don't have a lot of data about them because all the data which we are getting the data from open sources like HTTP, like headers, I don't know, like geo IPs and stuff. And we need like a proper automated pipeline to be able to keep up with the volatility of our users. Yeah. The results now, it's still in progress. Like I'm hoping to have it like in a couple of months to have it in production, but still it's just like my notion. And now instead of conclusion, what I've learned, like machine learning is always a cherry on top. It's so easy to be like mesmerized by the opportunities and the scalability of ML. But I really think that you need to have like three main points when you're tackling ML and AI and any types of fancy automation. The first, like operational excellence. Let's be like honest. Like operational excellence, pretty big domain, but what I want to put it here, it's not the only, not the main points of operational excellence, but really important here. So reporting hard evidence. Whatever you are doing, especially when you are doing with AI, you need to have like hard evidence about your results. You need to understand like what is the real impact of what you are doing, not to fool yourself. And of course, alerting system, pretty straightforward. The simple question: who is talking to customer support at 2 a.m.? I need to have any like product lead need to have the answer to this question, especially when it comes to like, because like any ML can become like a spam machine overnight, and you need to be able to react and you need to be able to control this impact. Next up is like hostile experiment designs. Like hostile design, this term comes out of architecture. And like for example, like benches where you can't sleep, this is like hostile design. And here, all of your experiments should be hostile, and the design of those experiments should be hostile, but not towards your users, but towards your beliefs, your desires, and your goals of this experiment. So the thing is, you should be always 100% critique towards what you are doing here, because again, it's a complex products. They require like a lot of different like expertise, different like specialists, like technologies to make it live. So you need to be always focused here. And of course, ML and AI cherry on top. It's always cherry on top because like AI by design, ML by design, it's just like another step towards automation. Yeah, with bigger scales, like we have the fourth industrial revolution happening right here, but still, those are fancy automations. You need to be 100% sure what is the goal of those automations. I mean, that's it. Hope you enjoyed.